Hello everyone. So today we'll be solving the question separate black and white balls. This question has recently been asked in today's weekly contest 372 and the question has been marked as medium. So in this question we are given a binary string. Binary string, we mean to say that the element can either be a 1 or 0. Note that 1 and 0 are the characters and not the integers. So any element can be 1 or 0 and so on. So this has been provided to us. In each step, I can choose two adjacent balls and swap them. I need to return the minimum number of steps to group all the black balls to the right and all the white balls to the left. So diving straight into the example, we can say here 101. So in this case, I have been asked to move all the black balls to the right and white balls to the left. So black is being denoted by 1. So black balls to the right means all the ones are in the right and white balls are denoted by 0. So all the white balls are to be shifted in the left. So basically I need to just sort this string and I need to give the minimum number of swaps, minimum number of steps in order to group all the balls, black balls to the right and white balls to the left. Here, one important line is being given that I need to choose any two adjacent balls and I cannot swap like this and this. The balls are need to be adjacent to each other. So let me just change the pen. The string is 101. My one possible condition can be that I can swap this and this to make the string 011. So merely one step can do this thing, and since 011 is the correct configuration which is following this, I'm going to return 1 because at least one step will be required. For the string 100, I need to swap 1 with this, and again when this is the configuration I need to swap this and this. So 001. So minimum two steps are being required in order to build the acceptable configuration. 0 triple 1. Here I am having this and this. So as you can see here that the configuration is already being given in the acceptable format. So I'm going to straight away return 0 since no operations are required to swap the adjacent elements. So one intuition you can be thinking of that I have been using two pointers here. So the intuition is very clear. I can use two pointers in order to see the number of swaps. So let us go through the code. For example, 0 1 1 1. This is the example. I'm going to do a dry run in order to make this more simple for you. So my I pointer is here, my jth pointer is here. So here we can say that the ith element is 0. So this is the possible configuration which is correct because I need 0 0 0 and then 1 1 1. So this is actually correct. So I do not need any steps. Now I becomes, let me just, so I becomes 1, and in this case I of s of I is not equal to 0 but s of j is equal to 1. So I'm going to move the jth pointer to 0 1 2 2. In the next step we can see that s of j is again equal to 1. So I'm going to again move this pointer and the loop breaks and hence we are returning 0. But that was possible when we were given an correct configuration. Let us construct some other example. So let's say the example is 1 0 0 1. Okay, so let us try to do this one. I wait, I is here and my j is here. S of I is not equal to 0, right? So S of I is not equal to 0, but S of j, because j is here, that is equal to 1. So I'm going to simply shift this j to this side, leftwards. In the next case, I am having neither S of I equal to 0 or j S of j equal to 1. So I'm going to execute these couple of lines in which I say that answer may we are including j minus I. So j minus I means 0, 1, 2, 3. So 2 minus 0 equals to 2. This 2 denotes the number of swaps which is being followed here in order to swap from position I to j. Since one swap will be this and another swap will be this, so the difference of the indexes will give me the number of swaps. So I'm going to swap this and this, so the string becomes equal to 0 0 1 1, and I is being forward. I is going to the forward index and j is going to the backward index. So j now becomes equal to this and our loop condition breaks. So we can say the minimum number of swaps here possible is 2, and this was the overall working behind the code, and I hope you like it.